Hi, welcome to this lesson on gram and mole conversions. The question of the day, in a lab setting, how do you know when you have a mole of a substance? I hope you said that you would know you had a mole of a substance in a lab setting by using a balance to measure out that substance's formula mass or molar mass. Now, you may remember that a mole is just a name for a number, and that number is 6.02 times 10 to the 23rd. We also call that Avogadro's number. The number is crazy big because we're counting atoms and molecules, and those are crazy tiny. We kind of can relate this to the way that the word dozen represents the number 12. If you consider a box of donuts, let's say that box is sealed shut, you're not allowed to look inside of it, how would you know how many donuts were in the box? You would probably pick up the box to get a feel for how heavy that box was. You could probably figure out if the box were full or maybe half full or close to it, or if it were totally empty. So let's imagine that from this particular bakery, each box of donuts, they're supposed to hold 12 donuts. So if we had 3 boxes of donuts and let's say they all felt full, how many would you have? And then if only 2 of the boxes were full, but one of them felt like maybe it was half filled, how many donuts would you have in that case? Well, the answer to the first question is 36, and you would get that because 12 donuts per box at 3 boxes would give you 12 times 3, which is 36. Secondly, you would have 2 full boxes, so 12 times 2 is 24, plus you would have a third box that felt about half full, so probably another 6 more. 24 plus a 6 would give you 30. Now, without really knowing it, or maybe you did know it, you completed a ratio and you have decided that there are 12 donuts per box and you have 2.5 boxes of donuts. So you would cross multiply that to get a value of 30 for your total number of donuts. Okay, fine. How does this relate to chemical reactions? Well, sometimes we're not working with a full mole of a substance. In fact, most of the time, we're not working with exactly 1 mole of a substance. So when we have this situation, we are going to use a ratio to figure out exactly what's going on. In any chemical reaction, the coefficients out front could give you the number of moles. They could give you the number of molecules of that substance. Later on, we'll learn about how that can relate to the concentration of a solution and even how it relates to the volume of gases. But for now, we're going to stick with moles and molecules. That's what coefficients really do. But even beyond that, coefficients actually tell you the ratio of one compound or substance to another in that chemical reaction. If we consider the synthesis of ammonia from its elements, we would have N2 plus 3H2 yields 2NH3. So really what this means is that for every nitrogen, you would need 3 hydrogens, which would make you 2 ammonias. And technically, it doesn't matter whether you're talking about moles or molecules. Boil it down, it's telling you the ratio of one substance to the next. So where it gets interesting is that we can take moles and turn them into grams, and we can take grams and turn them into moles. Let's imagine we're doing this reaction and we need, for whatever reason, 4 moles of potassium phosphate. We have to figure out how many grams of potassium phosphate we're going to need here. So we're going to have to convert those 4 moles into grams. The good part is that we can very easily figure out the conversion factor. We are going to try to determine the ratio that we're going to set up here. So I've mentioned this before. Whenever I use a ratio, I kind of just talk myself through it. The number of grams per mole is going to fit into this pink section right here, and that's actually the answer to your QMT chart. It tells you the molar mass in grams of 1 mole of that substance. This blue section is going to be the question of what you're looking for. So I tell myself, like, let's say in this case, we're trying to figure out grams. I would say X grams of potassium phosphate is equal to 4 moles. How many grams do I have to get it to equal to 1 mole? And that's the answer to the QMT chart. It's important to line up your units. You can either line them up horizontally like I have here, or you can line them up vertically. It's just important that the molar mass never gets multiplied by the value of 1 for the moles, because that kind of, it's the only wrong way to set this up. So to figure out how many grams I would have if I had 4 moles of potassium phosphate, I have to figure out the molar mass of potassium phosphate. So we had the formula K3PO4, and I want to figure out the molar mass for this compound. So I'm going to put this into my QMT chart. And in case you've missed it, I will link this video below how we figure out molar masses with my methods. Q stands for quantity, so I'm just going to count up everything that I have here. M stands for mass, and that is just going to be pulled from the periodic table. I am looking up potassium. That is 39. It's actually 39.10, but I am not going to mind my decimals here just for the sake of teaching this quickly. Phosphorus is 31 and oxygen is 16. We are going to multiply these going across. This should be 117. 39 times 3, yes, 117. This is 31, and 4 times 16 is not 48, it's 64. I always mess that one up. Okay, and we're going to add all of those values together to get the molar mass of the potassium phosphate. So this comes in at 212 grams per mole. So the way I would set this up is I would say, I don't know how many grams is it. How many? X. X grams of potassium phosphate will be 4 moles. But the question is going to come from this. 212 grams is equal to 1 mole. And then we just cross multiply because we have 2 fractions equal to each other with 1 unknown. So here I would get 1x is equal to 4 times 212. And that gives me 848 grams of K3PO4 is equal to 4 moles. And that would be it. That's as simple as it gets. Sometimes things get a little bit more hairy, so I'm going to show you a few more examples. Okay, let's say I needed to know the mass of, I don't know, 3.2 moles of calcium hydroxide. That is a C. CaOH2. So if I want the mass of just 3.2 moles of this, I have to find out the mass of 1 mole of it first because that's my conversion factor. So again, I'm going to do the QMT chart. Ca, O, and H are the elements I am working with. Quantity, mass, and total. I have 1 calcium and 2 of each of these. Calcium is 40, oxygen 16, hydrogen 1. That's 40, 32, and 2, which gives me 74 grams per mole on this calcium hydroxide. So it's really not too bad. If I needed 3.2 moles of the calcium hydroxide for whatever reason in my lab setting, I'm just going to shovel this onto the balance until I hit whatever mass this is. And that's why we're trying to figure this out. So I would say to myself, and we can do this the other way also, 74 grams is equal to 1 mole. That's my molar mass. That's a statement of fact right there that I've pulled from the QMT chart. And then it's X grams. I don't know how many grams it is. That's what I'm trying to find. And this would be set equal to 3.2 moles because that is what's in the question. So notice here that some figure from my molar mass, whether it's the 1 or the grams, is going to be cross multiplied by the opposite unit of the question. So on top here I have my knowns, and on the bottom I have the question. In the reverse, in the previous example, I had the reverse. I had the question on top and the known on the bottom. Either way works because you would still cross multiply the same values regardless. So in this case, I would do the 74 times the 3.2. Oops. In this case, I am getting 236.8 is going to be equal to the number of grams. Notice I'm solving for grams, so that's the number of grams that my answer would come out to, 236.8. And that's it. That just tells me shovel the calcium hydroxide onto the balance until you hit this value, because this value is equal to the 3.2. So sometimes we'll have the opposite situation where in a lab we come out with some number of grams, and then we'll need to figure out how many moles that is. So I am sticking with the calcium hydroxide just because at this point you should be pretty good at these QMT charts and finding the molar mass. I just want to skip to the next part. So in this case, it's asking X moles. I don't know how many, so I'm going to label it X. Also, please excuse the handwriting. I don't know how many moles it's going to be, but I know that it'll be equal to 42.8 grams. And then I'm just going to line this up with the information that I got from the QMT chart. I'm going to line up moles and moles. I know that a molar mass is based on 1 mole, and the mass of that is going to come out to 74. So going this way is a little bit tougher because we are going to be multiplying these 74 grams times X. So mathematically, it's just one extra step. So in this case, we got 74 grams times the X, giving us 74X, and that is equal to the 42.8 times 1, which is 42.8. We are going to divide by the coefficient of this X, which in our case is 74. This will give us a number that is smaller than 1, and that makes sense because 42 is less than 74. So in our case, this is going to come out to 0.578 moles. And that represents the number of moles that you have when you have 42.8 grams of this substance. So you can see how this process is kind of straightforward. Once you get the hang of it, it's really quite simple. Before you get the hang of it, it is a little bit tough. So again, this X moles and the 42.8 is what comes from the question. Line that up either on the top or the bottom. It does not matter. And then across, you will also have the molar mass equal to 1 mole. In this case, the mole is always going to get the 1 because a molar mass is some number of grams per 1 mole. And that's it. This is the very first step of something that we would call stoichiometry, which sounds really, really, really crazy. I like to take this the stoichiometry concepts and teach them very slowly over like a whole week to make sure that everybody feels really good about it. So this is not something that you can breeze over and kind of just say like, oh, it's okay, I'll pick it up. You will not pick it up as you go. It gets a lot tougher. So make sure that you feel really good about this before moving on to the next thing. If there are any questions at all, please leave them in the comments section. I would be happy to get back to you. Also subscribe so you don't miss the next lesson. I'll see you there. Bye.